Hello friends, welcome to the Zeta Online Science Academy. Today we are going to discuss about second part of first chapter of O-Level series 5070 according to the syllabus 2023, 24 and 25. If you are new at our channel, then kindly subscribe our channel and press the bell icon so that you get the notification of every video. So without wasting even a single minute, let's start the video. In the previous lecture, we discussed in detail what is states of matter, the changes in states of matter. In this module, we are going to discuss the effect of temperature and pressure on the volume of a gas in terms of kinetic particle theory. First, we see that the effect of temperature on volume. In other words, the relationship between volume and between volume of gas and temperature. This relationship is explained by Charles' law. There is no need to remember this is provided by Charles' law, but this is extra information. You can keep it in your mind. According to this law, if pressure and amount of substance remains constant, then volume is directly proportional to the temperature. It means that if we increase the temperature, the volume will automatically increase. If we decrease the temperature, the volume will also decrease with respect to it. What's the reason behind it? Its reason is that if we increase the temperature, the kinetic energy of the particle increases according to the postulate of kinetic particle theory, that kinetic energy is directly proportional to the temperature. Now, if kinetic energy increases, it means that movement of molecules increases. If movement of molecules increases, the molecule will expand. It means that expansion indicates increase in volume. Similarly, if we decrease the temperature, the kinetic energy of molecule will also decrease. If kinetic energy of molecule decreases, then its movement will also decrease, and if its movement decreases, the molecule will contract, and contraction shows decrease in volume. I hope so this is clear now. The next we see the effect of pressure and volume. The relationship between pressure and volume is explained by Boyle's law. According to the Boyle's law, if we keep the temperature and amount of substance remains, if we keep the temperature and amount of substance constant, then volume is inversely proportional to the pressure. What does it mean? It means that if we increase the pressure, the volume will decrease, and if we decrease the pressure, the volume will increase. What's the reason behind it? The reason is that if we keep temperature constant, it means that kinetic energy will also remains constant. If kinetic energy remains constant, then motion of molecules will also remains constant. If motion remains constant, it means that speed of molecules will also remain same. Molecule remains same. Now, here is a container. The gas molecules are present in it, and now we apply pressure on it. By applying pressure, its volume will decrease. Its volume will decrease because it will compress, while amount of substance and temperature remains constant according to the postulate of kinetic particle theory. If we increase the pressure, the molecule will compress. It means that volume is decreased. If we decrease the pressure, it means that the molecule will expand and the volume will increase. We can see it in another aspect also. See, here is a container and it's a this area is the volume of the container and the gas molecules are present in it. Now if we compress the container, if we compress the container, or in other words, if we decrease the container, it means that if we making container small, we made the container small. Now because we made the container small, its volume decreased. Its volume is decreased. Because its volume decreased, but temperature and kinetic energy is constant, so the motion of molecules is also constant. If motion is constant, an amount of substance is called this. Due to small container, the molecules are now somewhat close to each other. Due to this closeness, the collision of molecules will increase with each other and will the walls of container. Due to collisions, the pressure will, as collisions are increases, the pressure will also increase. I hope this is clear now. This was all about effect of temperature and pressure on the volume of a substance. Let's do some practice questions which appeared in P1 and P2. Here is the first question. Here he is asking what set of changes to the condition increases the volume of a gas. What is he asking in the question? Think about a minute. He is asking us about the condition which increases the volume of a gas. We know that volume is directly proportional to the temperature and volume is inversely proportional to the pressure. It means that increase in temperature will also increase volume of gas and decrease in pressure will also increase the volume. Here we find the correct option, the decrease in pressure and increase in temperature increases the volume of substance. Now these questions appeared in P2 exam. The question is, a sample of neon has volume of 21 decimeter cube at room temperature and pressure at STP condition. The temperature of sample is increased while pressure remains constant. Describe and explains using kinetic particle theory what happens to the volume of the sample. We know that temperature is directly proportional to the volume, or volume is directly proportional to the temperature. Now if we are increasing the temperature, the kinetic energy of particle will also increase, and if kinetic energy of particles increase, the movement or motion of particle will also increase, and if motion of particle increases, it means that volume of the substance will also increase. The pressure of the sample increased while temperature remains constant. Describe and explain using kinetic particle theory what happens to the volume of substance. Here the examiner is asking about Boyle's law. By using Boyle's law, we know that volume is inversely proportional to the pressure. While temperature remains constant. If temperature is constant, it means that kinetic energy is also constant. Now, if we compress the container in which gas is present, then its volume will also decrease. By increasing pressure, its volume will decrease. Now we see another question. This is also same question like before. A sample of gas has volume 11.5 dm cube at room temperature. The temperature of the sample is decreased. The pressure remains constant. Now, in the above question, he was asking that if temperature is increased, what will the effect of volume? Here he is asking if temperature is decreased, what will affect? If temperature is decreased, then kinetic energy will also decrease, and kinetic energy decrease, motion of particles will also decrease, and if motion of particles decreases, then volume will also decrease. The pressure of sample is decreased. The temperature remains constant. Describe and explain using kinetic particle theory what happens to the volume of the sample if pressure is decreased, then volume will automatically increase. We explained it later. Kinetic energy will also remains constant. If kinetic energy remains constant, the motion of molecules will remain constant. Motion is also constant and volume will increase. The molecules will expand. I hope this is clear now. Now come to the second topic of today's lecture. That is most important and most typical questions come from this topic both in P1 exam and P2 exam, and this topic is diffusion. This is 1.2 topic diffusion. Describe and explain diffusion in terms of kinetic particle theory. First, see the definition of diffusion. What is meant by diffusion? Diffusion means that the process of diffusion occurs when particles move from a region of higher concentration to a region of low concentration. We can see different examples of diffusion in our daily life. Let's assume the cooking is someone is cooking at our home and you are at upstairs. You smell the cooking order. Something is cooked on the upper floor. Why? This is because of diffusion, but because particles moved from a region of higher concentration to a region of lower concentration. We know that this is a property of gases, that they occupy all the volume available to them due to low forces of attraction, low intermolecular forces. Okay. Now we will explain diffusion in terms of kinetic particle theory. According to the postulate of kinetic molecular theory or kinetic particle theory, all matters are composed of teeny particles, atoms, molecules, or ions that are in constant motion. It means that matter is composed of particles. These particles are moving. These particles are moving. Due to this motion, if they are moving, it means that they will spread out, and if they spread out, it means that the process of diffusion will occur. Here I said due to motion, the collision between the particles occur, and if collisions occur, then due to collision they transfer kinetic energy and momentum. Due to their transferring kinetic energy and momentum, by gaining energy, the particles spread out and the phenomena of diffusion occurs. Here is a question. Why diffusion occurs from higher concentration to lower concentration? What's the reason? Because what is meant by higher concentration? It means that in small area, the more particles are present. More particles and less space. If more particles are present in less space, they will effectively collide with each other. They will effectively collide with each other. Due to their collisions, they will spread out and move toward the region where no particles are present and the concentration of gas or any matter is low. This is the reason why diffusion occurs from high concentration to low concentration. Now we see rate of diffusion in solids, because the three states of matter, either they are solid, either they are liquid, or they are gases, they are made up of particles. They all are made up of particles. If they are made up of particles, it means that their particles are in motion according to the postulates of kinetic molecular theory. If their particles are in motion, then the process of diffusion will occur. In gases, because particles are closely packed, we discussed in detail in our first lecture. Because the particles are closely packed, it means that their motion, they have only a vibrational motion. They have only vibrational motion. Therefore, the rate of diffusion in solids will be very low. Similarly, in liquids, the particles are loosely attached and spaces are present in them. Therefore, they have motion. Due to motion, the phenomena of diffusion will occur. For example, if we put a drop of ink in water, here is the water, and you are putting a drop of ink in it, it will spread out in whole the water. This is phenomena of diffusion. The third one state of matter is gases. In gases, the process of diffusion is very high. Here I am giving you a very important tip which help you in during solving P1 question. The examiner asks, here a gas is present, a jar is present, here air is present, and here a gas is present. Assume this gas is of red color. He asked, after some time, what will be the color of jar? You know that the process of diffusion will occur and gas will spread out in whole the jar. But how will you distinguish color? How will you describe color? How will you describe color in present? So here is very important tip. The particles diffuse equally and they form a homogeneous mixture. What is meant by homogeneous mixture? It means that the particles now came in single phase. It seems that only one phase is present. Similarly, when we put a drop of ink in water, the whole color of water turns to the blue. We cannot distinguish ink and water. Ink and water. Similarly, here the color in whole jar will be same. The color will be same, and that will be the answer of your question, no matter it's light red, brown red, or etc. The color will remain same. The second question asks, describe and explain the effect of relative molecular mass on the rate of diffusion of gases. The gases, now here we see that gases diffuse faster. Gases diffuse faster. Now if two gases are present, two gases are given, we know that gases diffuse faster, then how we will distinguish that which gas diffuse, which gas diffuse faster. Here are two parameters that helps us to find which gas diffuses faster. The first is molecular mass and the second one is temperature. Temperature is asked in our syllabus. Here is asked molecular mass. We will discuss also temperature very briefly. Now see what is the effect of molecule. Think for a moment, either a bulky man can run easily or a very smart and thin man can run easily. The answer is a smart and less fatty man. Fatty man can run easily. Can run easily. Here is also the effect of relative molecular mass. Molecular mass means that the weight of or mass of molecule. The effect of relative molecular mass is explained by Gram's law. Gram's law says that rate of diffusion is inversely proportional to the density of the substance. Rate of diffusion is inversely proportional to the density of substance. We know that density is equal to the mass over volume. Here we can see that Gram's law obeys when temperature, pressure, and volume remains constant. If then volume is remain constant, we can simply ignore it. Then the rate of diffusion will be inversely proportional to the square root of molecular mass. It means that if molecular mass, if a particle has greater molecular mass, it will diffuse later. It will diffuse later, and if a molecule has low molecular mass, it will diffuse earlier. Here is a question: which one will have higher rate of diffusion? We can decide it simply by knowing its molecular mass. The molecular mass of chlorine is 70 gram per mole. The molecular mass of hydrogen is 2 gram per mole. The molecular mass of nitrogen is 28 gram per mole. The molecular mass of oxygen is 32 gram per mole. Which one will diffuse earlier, a higher rate of diffusion? The one who has low molecular mass, and that is hydrogen. If I ask this question, which one will have slow rate of diffusion, what will be your answer? Your answer will be chlorine, because it has high molecular mass among the following. Now we discuss another example of diffusion. Here is a closed tube. Its one end is closed with cotton wool soaked with HCl, and the other end is closed with cotton wool soaked with NH3. The NH3 is producing colorless fumes. Similarly, the HCl is also produces colorless fume. After some time, we see that nearer to the HCl, some white fumes are produced. These white fumes are actually white fumes of NH4Cl, because when the ammonia molecules move and HCl molecules move, after some times they come close to each other, they react with each other and form NH4Cl, ammonium chloride. Then why here? The question is, why here? Why the white fumes are produced here, not here, not here, not here? Why? The reason is this: HCl has high molecular mass, and there is 36.5 gram per mole, while the molecular mass of NH3 is 17 gram per mole. Therefore, the molecules of NH3 diffuses faster. These molecules diffuses faster. They diffuse faster, and these molecules diffuses very slow as compared to the NH3 due to molecular mass. Therefore, they meet each other at this point, and the phenomena and the chemical change occurs, and white fumes of NH4Cl are produced. These questions comes in your P1 and both P2 exams. We also practice these questions now. Now the last one is effect of temperature on the rate of diffusion. This is not included in our syllabus, but we saw it very briefly. If we increase the temperature, the kinetic energy of the particles will increase, and if kinetic energy of the particles increases, the collisions among the particles will increase, and if collision increases, then the rate of diffusion will also increase. It means that rate of diffusion is directly proportional to the temperature. If we increase the temperature, the rate of diffusion will increase. If we decrease the temperature, the rate of diffusion will decrease. Let's do some practice of these questions that related to the diffusion that comes in the exam. The first question is, this is P1. The first question is, which gas diffuses fastest at the same pressure? The pressure is kept same. Now first see molecular mass. Here are two gases. The first is nitrogen and the second is oxygen. The molecular mass of nitrogen is 28 gram per mole, while the molecular mass of oxygen is 32 gram per mole. Now it means that the one with low molecular mass, according to the Gram's law of diffusion, will diffuse earlier, and the one with high molecular masses will diffuse higher or later. In this option, these both options are incorrect because the molecular mass of nitrogen is lower. Then another factor is present here in this option. In two options, nitrogen is present. The first one is at 25 degrees centigrade and the second one is 50 degrees centigrade. It means that now we are considering the rate effect of temperature. Temperature is directly proportional to the rate of diffusion. It means that at 50 degrees centigrade the diffusion will occur faster, and at 25 degrees centigrade the diffusion will occur slowly. So therefore the correct option will be nitrogen at 50 degrees centigrade. Now comes to the next question. The next question is, ethylene amine gas and hydrogen chloride gas react together to form a white solid ethylene amine hydrochloride. At which point and the tube of ring white solid ethylene amine chloride will form? Look at the molecular mass of these substances. The molecular mass of ethylene amine gas is almost 44 gram per mole, while the molecular mass of HCl is 36.5 gram per mole. It means that the HCl will diffuse faster and comes closer, while ethylene amine will diffuse slower. They meet each other at this point, and the white precipitate, white solid is also produced. So the correct option will be option A. This will be the correct one option. I hope this is clear now. Now move towards the next question. Here two gases are provided. The first one is carbon dioxide. When the questions comes related to the diffusion, your first task is to find the molecular mass of the provided substances. Here we can see the molecular mass of carbon dioxide and methane. The molecular mass of carbon dioxide is 44 gram per mole. The molecular mass of methane CH4 is 16 gram per mole. At two different temperatures, one high and one low. One temperature is high and the other one temperature is low. Which row correctly shows that gas that diffuses faster? Now we have to find that which gas will diffuse faster. The one with low molecular mass. The one with low molecular mass. Because rate of diffusion is inversely proportional to the square root of molecular mass. Similarly, another factor. Similarly, the another factor we discussed is rate of diffusion is directly proportional to the temperature. Rate of diffusion is directly proportional to the temperature. Which one has low molecular mass? Methane. It means that these both options are incorrect. Then in two options we have methane. The first one is that at higher temperature the rate of diffusion will be high. So this option will be the right one. I hope that this is clear now. Now move to the next question. This question appear in our P2 exam. This question we also discussed during the lecture. Now make a quick go through. Cotton wool soaked with HCl and the cotton wool soaked with NH3. The molecular mass of NH3 is 17 gram per mole, while the molecular mass of HCl is 36.5 gram per mole. Your first task is to find the molecular weight. It says the color fumes of hydrogen chloride are given off by hydrochloric acid. Colorless fumes of ammonia are given off by aqueous ammonia. After a few seconds, white fumes are produced at point X. Name the compound formed at point X. We discussed in the lecture when NH3 and HCl react with each other, ammonium chloride is formed. So the name of compound is ammonium chloride. Now, what is the second question? The second question is use the kinetic particle theory to explain this observation. According to the kinetic particle theory, the gases will diffuse. The gases will diffuse. The one with low molecular mass will diffuse faster, and the one with high molecular mass will diffuse slower. Therefore, we see the fumes produced at point X. This is explanation. Another question is that student repeated the experiment using a solution of methylamine Ca3NH2 in place of ammonia. You can see that this molecule will have high molecular weight, while this molecule has low molecular weight. The white fumes were seen at point Y. The white fumes were seen at point Y. What's the reason? Explain the reason. The reason is that in case of methylamine, the rate of diffusion is slow. The rate of diffusion is slow. Therefore, the ammonia molecules will move faster and reach this point, and these molecules will reach from here, and the reaction will occur. I hope I make you understandable this question. Next, the last one question is, the question is bromine is a liquid at room temperature. Bromine is a liquid at room temperature. Draw a diagram to show the arrangement of molecule in liquid state. You know that in liquid, particles are not closely packed, are not close to each other. Therefore, the particles are not. Therefore, by showing this arrangement, you can show the molecule of bromine. The question is, a small amount of liquid bromine was placed in the bottom of a sealed flask. After 30 minutes, the brown color of bromine had spread throughout the flask. What is the reason? You know that although bromine is a liquid, and liquids show the phenomena of evaporation. The liquid starting evaporating and mixing up with air molecules after 30 minutes, and when vapors are formed, these vapors can diffuse very easily. Therefore, after 30 minutes, we can see that the bromine color is spread throughout the flask. That was all about today's topic, today's lecture. If you have any query, feel free to ask me in comments. Feel free to ask me in comments. I will also provide the link of these notes in the description. You can download the notes from here. If